So if you've ever tried to use an AI to edit a video, I mean really edit it, like change a coffee cup in someone's hand, yeah, the pain, it looks good for a second, but then
Mhm.
the edit starts to bleed out. Suddenly the AI is changing the person's shirt or the wall behind them gets all blurry. That lack of precision, that's a real technical problem called token interference. And today, we're diving into a new way of thinking that's designed to solve this. It's called ReCo. That's for region constraint and context generation. Our mission here is to figure out how ReCo gets so accurate and, stops all that background noise.
Oh, absolutely. That token interference has been the central roadblock for a while now. Previous models, they just couldn't specify where to edit. The whole frame was treated as one big canvas, and that just led to messy results. You're basically fighting the model's own denoising process.
Okay, so let's unpack this. How does ReCo do it differently? It starts by looking at the source video and the target video side by side.
Yeah, a widthwise concatenation. It processes them together jointly. But that's not the real trick. The ingenuity is in what they call constraint modeling.
Constraint modeling.
Exactly. It's not just about processing them at the same time. It's about regulating how the AI learns from the difference between the two. ReCo uses these two specific regularization terms. Think of them as tools to teach the AI where to look and, more importantly, what to ignore.
And this is where it gets really interesting and honestly a bit counterintuitive. The first tool is latent regularization. It actually increases the discrepancy in the editing region. Wait, why would you want to make them more different?
Right, it sounds totally backward, but think of it like applying masking tape before you paint to make sure you only change the coffee cup. You have to tell the model, hey, the information right here has to be completely new.
Yeah.
But, and this is the key, at the same time, ReCo massively reduces the discrepancy everywhere else, in all the non-editing areas.
Okay. So you're creating a hard border. You're emphasizing the change in one spot by locking down everything else around it.
Precisely. It's a surgical instruction. You're not just telling it what to change, you're telling it where to ignore the original.
So that's the core innovation, isn't it? But what happens when you introduce something totally new? Say you want to turn that coffee cup into an apple.
Yeah.
How do you stop the AI from, remembering the cup?
Yeah, from fighting the ghost of the original object.
Exactly.
Well, that's where the second constraint comes in. It's called attention regularization. And this is all about blocking memory. It actively suppresses the connection, the attention between the tokens in the new editing area and the tokens in the old source video.
So you're telling the new pixels to
Oh,
not look at their past selves.
you got it. It's like giving them selective amnesia. They have to generate the new object based only on your text instruction, not the memory of the frame that came before.
Wow. So we've given the model a boundary with latent regularization, and now we've given it amnesia with attention regularization.
And that ensures when the AI goes to make that new apple, it's not being muddied or confused by any leftover data from the coffee cup. It's a clean slate, right where you need it.
That is just.
It's brilliant. And if we look at the bigger picture here, this isn't just a concept. The researchers backed it up with a huge resource. They released something called the ReCo-Data dataset. We're talking 500,000 instruction video pairs. It's massive, and it's there to help train future models across the board.
And the results really proved it out, right? I saw it was tested across 4 major video editing tasks.
It was, and it showed that this level of frame-by-frame control is not just possible, but it's reliable. It just works.
I think ReCo really shows that this kind of precise, user-guided control is the next step for AI video tools. It's how they go from being a fun novelty to, a professional-grade instrument. So here's the thought I want to leave you with. What new creative doors open up when we can finally trust an AI to execute these complex, super detailed edits frame by frame without ever worrying about the edges bleeding?